So I'd like to start by saying thank you everyone for coming. My name is Cody Armstrong, and today we're talking about assemblies and Onshape. So we're really going to focus on motion and Onshape and how to get the mates and the things that we need to establish that motion. As I always say with these webinars, we really encourage you to ask any questions that you'd like. So there's a questions dialog, and you go to webinar control panel. Feel free to type anything in. I'll do my best from time to time to stop and make sure to answer any questions that you have. If I don't get to your question, stick around. I'll do my best to make sure after the webinar is over to address any questions that are outstanding. So again, feel free to type in anything. So Onshape Assembly is really intended for those that maybe have spent some time part modeling, but are trying to get a grasp on how to put things together in an assembly. All right, so let's dig in. Now, before I get into the topic of the day, there are a few things I'd like to mention for those newcomers to Onshape about Onshape in general. And one of the first is our mission statement, and that is getting everyone working together with CAD on any device, anywhere. And so if you haven't used the Onshape mobile app for Android or your iOS device, your iPad, your iPhone, or your Android phone or tablet, I definitely recommend it. It gives you a full-blown CAD editing tool in a mobile platform, right? So it's not just a viewer. You can create sketches, parts, and assemblies all from a mobile device. And it's also working collaboratively on any computer you happen to be in front of. So it could be Linux, could be Chromebooks, could be Mac, Windows, so it just depends. But you have accessibility to your CAD data anywhere. So everyone working together with CAD on any device, anywhere. That's our goal. Now, the last thing I'd like to mention about Onshape in general is we do consider ourselves professional 3D CAD. And when you think of professional 3D CAD, it's really three pieces. You have parts, assemblies, and of course, drawings. And we do have all three major pieces that make up a professional 3D CAD system. But there are some things that really set us apart. And one of the first that I'd like to point out is how quickly we evolve. With Onshape, you're going to see updates roughly every 3 weeks. So unlike many professional 3D CAD systems out there, you don't have to do anything, and it rapidly evolves, right? So it's a very easy for the end user to establish and always be on the latest version. So with Onshape, we evolve very quickly. Roughly every 3 weeks, you're going to see new functionality instead of once a year. Also with Onshape, we have built-in version control. So you have the ability to version control your CAD data without an external system. So you don't need a separate data management system to manage files, so to speak. That concept goes away in Onshape. So with Onshape, we have version control built in, and it's built into the core functionality of Onshape. Also, if you've come from another CAD system, we have the ability to read and write common CAD formats that are out there. So STEP, IGES, Parasolid, SolidWorks Inventor, CATIA, Creo, and so on are a number of different formats, and that's not the complete list, but a number of different formats that we can both import and export. It means that Onshape is a great solution for working alongside an existing CAD system. So we can read and write common CAD formats. The last thing to mention is with Onshape, we've introduced entirely new methods of collaboration. So you have the ability to share and even collaborate in real time, right? So unlike a file-based CAD system, when you share an Onshape, you see everything update live. Any change to the model, it changes for everyone at the same time. So entirely new methods of collaboration include real-time simultaneous editing between users. Our comment capabilities allow you to mark up and tag different features. We even have a follow mode capability that allows you to see each other's screen in real time. So entirely new methods of collaboration, really setting the standard for how web-based CAD should be done with our collaborative tools. So those are just some things I like to mention about Onshape. What are we going to talk about here today? The first goal of course with this is starting the assembly. How do I start my assembly? Just starting from scratch. I built a few simple parts. Now I want to assemble them. How do I get started? So we're going to start there. The next thing, of course, is mates. And mates are the key to piecing everything together in these assemblies. And we're going to cover both the concept of mates and mate connectors, which are a key piece of mates. So mates, mate connectors, also relations. Think of relations as mechanisms or movement between mates. Gears, or for example, or rack pinion is another example of a relation. So a number of different relations I'm going to cover. But just keep in mind, throughout this whole webinar, feel free to ask any questions, and I'll do my best to stop and address them. So that is the goal, and I want to jump right into things. So as I mentioned before, we're going to start with the basics, and that is just creating your first assembly. And one of the easiest things to do is just to point that out. Now, by default, you will be given, when you create a new document, a blank assembly tab. And you can see by the tab at the bottom the little indication that it is an assembly. Now, if you want to create a new assembly, you can also do that. In the bottom left corner, there's Create tab, and you can choose the option to create an assembly. Okay, so it's up to you. I have a blank assembly. I'm ready to get started. Key things to keep in mind. Of course, the toolbar change. Right? So if this is the first that you've seen of an assembly, the toolbar is going to look a bit different. We don't have features or sketch icons here. We have assembly tools and so on. So that's one of the first things to point out about the differences between assemblies and part studios. But there's not a ton else, right? You have the feature list on the left, you have the view cube on the right. The first step that you're going to want to do, of course, when you're inserting or building your assembly is insert parts, right? So in the far left here, one of the very first icons you'll select is insert parts. Now, some things to point out. One of the first things I want to point out is if you've modeled your parts together in one part studio, you can insert them together in one part studio. So that's one of the big benefits to modeling multiple parts together. But you don't have to. You can select them individually and insert them as well. Right? Now I'm going to select the entire hydraulic component set. So this is one part studio that has a few parts, 4 in this case. We'll select them and they're inserted into the assembly. Okay. I can hit the green check and we've inserted our first parts. As I mentioned before, these were modeled in this orientation in the part studio. So they come in rather easily, but it's important to point out they're not constrained in any way. If you left click and drag these, they're free to move about in the graphic space. So again, the idea behind this is we want to constrain the assembly, but have the necessary motion to test our movement, right? And this is a little hydraulic plunger, so it should be free to move up and down, but nothing else should move. So let's get started. Now we've inserted our parts. So you'll see the parts showing up in the feature list. And now what I'd like to do is start to constrain them. As I mentioned before, they're free to move anywhere, and they're not really constrained in any way. One of the first steps when you're getting started with your assembly is to define what is the fixed part. In this case, this cylinder doesn't move. Right? Everything else moves around it. The plunger moves up and down. This may be free to swing, but this itself doesn't move. Right? So in this case, this is my fixed part, but you'll have to go through in your assembly and define what is the thing that's static, that doesn't move, and everything else moves about it. Right? That will be your fixed part. So in this case, all I do to fix this part, right click and choose fix. You'll see the cylinder with a little fix icon next to it in the feature list indicating it's been fixed, and when I left click and drag, I cannot move that part around the screen anymore. Okay, so again, we're beginning to constrain our assembly, and that's one of the first steps. Make sure to define your fixed part. Now, the next thing I want to point out here is many times you can build your assemblies with just 1 or 2 simple mates, and it all depends on the degrees of freedom that your assembly has, but Onshape has a unique feature called group that allows you to group parts that are modeled in this way. So here's an example where the O-ring, right? The O-ring is not constrained in any way, right? So if I left click and drag, it's free to move around, but it's already in its correct position. So really what I want to do is just fix it relative to its current position, relative to this cylinder. And there's a very easy way to do that with group. So I can select group, select the parts that I want to group together, and you can group as many as you would like. Hit the green check, and now that O-ring is fixed relative to the cylinder. So the big thing here is if I have a lot of parts that are in their correct position and they don't move in any way, they're just fixed, I can group them and not have to worry about adding individual mates. Right? I don't have to go in and mate the O-ring to the cylinder now. It's already in its correct position. It's there. And so if I had a dozen of these, or if I had many of them, I would have many mates in a traditional CAD system. Whereas they're modeled this way, I just group them and they stay fixed. Right? But there will be situations where you need motion, and that's really what assemblies are all about. I want to be able to put this together and then test the motion out. It's important to point out, many situations, if your design doesn't have any movement, much of it can be done entirely in one part studio, and never need to create an assembly. Assemblies are really about putting things together and testing out the movement between them. So let's do that. Now in this case, of course, I have the plunger, which should slide up and down inside of the cylinder here, and of course I have the clamp on top. And what I'd like to do is assemble the plunger into the cylinder, but it needs to be free to move up and down and also rotate. Right? So this is a scenario where I can't use group. Remember, group fixes a part, so it can't move. I need to constrain it with a mate. So let's start with a simple cylindrical mate. Right? So you'll see cylindrical mate in the toolbar, and by the way, you'll see small lines here telling the difference between the different pieces of the toolbar, and this is the list of mates that we have to work with. I'm going to start with a simple cylindrical mate. Now, when you select a mate, any one of the mates in the list, as you move your cursor over the part, you'll see these little visual cues, these little white dots appear over parts. These are what we refer to as mate connectors. And so with Onshape, we've taken a bit of a different approach to how you constrain assemblies. Instead of defining by a series or a combination of faces, for example, we use a point from one part and a point from another part, and we define the degrees of freedom based on the type of mate that you choose. So for example, I want to put the center of this plunger. So as I move my cursor over, it highlights there at the bottom of this hole. I select the points from either part, and it brings those 2 points together. And then you can test the degrees of freedom, or how much motion it has, by hitting play. So some tips about the assemblies. Again, all I did was take a mate connector or a point from one part and a mate connector or a point from another part, and I bring them together. The cylindrical mate defines how much motion there is. And if I hit play, you'll see it's free to move up and down, and it's also free to spin, which is the correct degrees of freedom. But a tip about the mates, and if you want to learn them, a quick way to learn them is to try different mates out. So I can select slider, for example, and hit play. And you'll see it's free to slide up and down, but it's no longer free to rotate. So it's showing me that that is one linear degree of freedom. And you can try out the different mate types. So I can say, okay, revolute, play. And you'll see it's just free to spin. So you can try out different mate types. You can learn them just by animating and seeing the degrees of freedom. But ultimately, the goal here is, of course, the correct motion when I drag. So I'll select cylindrical. I'll hit the green check OK. And now, if I left click and drag, you'll see it's free to slide up and down. If I move left to right, it cannot move left to right, right? So I have that linear degree of freedom, and then of course, it's still free to rotate. So again, all I did was take one point from another apart, a point from another, and bring them together. And this technique has a number of different advantages. In fact, we like to refer to it as a higher level system of mates because it allows you to take a combination of what would be a combination of mates in a traditional CAD system and really deduce it down into one. And a great example of this is attaching the swing arm to the top of the plunger. So in this example, what I'd like to do is I'd like to attach the top face here. Of course, I want them concentric, right? And then in a traditional CAD system, I'd have to do something to set the orientation, or what some refer to as the clock, or the angle that it's fixed relative to the shaft. And so in a traditional CAD system, that might be 2 or 3 mates. With Onshape, it's one fasten mate. Another example I'd like to give is a bolt to a hole. If you think of mating a bolt to a hole, it would often be 2 or 3 mates in a traditional CAD system. This is another example where fasten mate is really applicable. Right? I can select one mate connector on the top of the swing arm, one mate connector on the top of the plunger, and the 2 mate together. Okay? Now I can hit the green check OK, and you'll notice that one mate has attached the swing arm to the top of the plunger. So I don't need a combination. And again, this is an example where just the one mate fasten restricts all degrees of freedom. And again, mating a bolt to a hole is another example where I'd use a fasten mate and save myself a lot of redundant mates. Now, a question that's come up, is there up or down interference? Is there a way to tell if parts are colliding? And the answer is yes. It's actually built into the section view tool. So if I select a planar face, and let's do a section view, if I drag this section view back here, you'll see right now there's no conflicting parts. Okay? But if I drag this up to a certain point, you'll see parts turn bright red. The bright red is interference. So in the section view command, if you move your assembly around, any interfering parts will highlight in that bright red color. Okay. So inevitably, the question is asked, well, you can tell that they're interfering. Is there a way to stop it? Is there a way to limit the amount of motion? The answer again to that is yes. In the mate command, there's an option for limits. I'm going to go over this again in just a bit, but you can check limits. You can set the amount of travel that you would like to have, right? And you can restrict the range of motion with a minimum and maximum value. Okay? So you can limit the range of motion of your mates with the limits checkbox. Okay, so again, just a quick recap. All we're doing there is just selecting a mate connector, a point from one part, bringing it together with a mate connector from another part, and defining the degrees of freedom. Okay. Now, I mentioned before that the fasten mate, you have the ability to set what's often referred to as the angle, or sometimes referred to as clocking the part, so to speak, or locking the rotational degree of freedom. With fasten mate, we restrict all degrees of freedom, but you can also set what's referred to as the secondary axis, right? And by default in the dialog, you can set it at 90-degree increments. So you can set the rotation value of that. Now, if you want even further control, you can actually go into the fasten mate in the feature list and actually edit a mate connector. Okay, and as I mentioned before, these mate connectors are really the key pieces. They're the points that we're bringing together. And you can choose something like move and rotate, 12 degrees. So if I wanted something very specific, I can do that. By default, you do get the 90-degree increments for the secondary axis. But just keep in mind, you can edit the individual mate connectors that make up a mate in the feature list. Okay. So that is the cylindrical and fasten mate. Again, the cylindrical mate gives you rotation plus the linear movement, allowing this plunger to move up and down and also spin. The fasten mate restricts all degrees of freedom. So it essentially attaches this swing arm to the top of that plunger, right? It fixes it relative to it. So those are the first two that I'd like to cover. Let's jump into my next example, and that is the machine vise. So with this example, I have a few different mates that I want to highlight. One of the first mates that I want to point out is the slider mate. Slider mate allows you to it gives you one linear degree of freedom between your mate connectors. And a great example of this is attaching something like the vise jaw to the base. You could use a number of different mates, and I'm going to show you another example here in just a second. But this allows me to attach one mate connector on an edge of the jaw, for example, to one mate connector on the edge of the vise base, and still gives me that one linear degree of freedom, so that it still can slide back and forth, but it can't move in any other direction, right? The correct amount of constraint, right? So as I mentioned before, you can also restrict the range of how much it can move so that it doesn't go past the base, for instance, with a limit. But for now, if I hit the green check OK, you'll notice left click and drag, it's only free to move along that linear degree of freedom. Okay. So a great example of a slider mate. Now, another example I want to give you here is a planar mate. Now, a planar mate has much more freedom in how it's constraining the model, but it can also be used in this example. So the way to think of a planar mate is you're essentially taking two planar faces, two flat faces, and bringing them together. You're really not restricting any other range of motion besides that linear difference between those two planar faces. So you select planar mate, and I say, okay, I want to bring this face to this face. And essentially all I'm saying is I want to bring those two faces together. Now it's important to point out this does not restrict it in any other way. So if I hit play, you'll see it's free to spin, it's free to move in any linear direction, it just can't move away from that face. So again, if all you're trying to do is bring two planar faces together, this is a great tool for it. However, like in my example, you may need something else that defines another or constrains it another way. Now, a question that's come up, can you offset? Can you add an offset? So if I wanted these two faces not touching, but a small gap between them, the answer is yes, you can check offset. And you'll see here I can add a value in under the offset. Okay. And that will just offset between the two, giving me a small gap between the two faces. So I hit the green check, and now I have a planar mate here in the feature list. And if I drag this around, you'll see it's not ideal, right? It's not, the two faces are staying intact, but it's free to move in any other direction. So let's fix that. The next constraint that I'd like to cover is the revolute mate, right? And the revolute mate allows you to attach two mate connectors, but still allow a rotational degree of freedom. So think of the spindle for my vise. It still needs to be able to spin inside of this jaw, right? So it still needs that rotational degree of freedom, but the end is fixed or attached to the jaw itself. This is a great example of revolute. Select revolute. I select the end of the spindle. I select the bottom of the hole in the jaw. Okay. Green, check OK. And now you'll see the spindle is attached to the jaw. Okay. So it's just an example where the jaw was constrained or free to move, but now because of the spindle, it's fixed in a different direction. Right? Now I'm getting the behavior I might expect. Right? So that is the revolute mate. And again, it gives you that rotational degree of freedom, so I can still spin, but it's attached to the end of the jaw. All right, so let's move on. Now, the next example that I have for you is the pin slot mate. You'll notice I have a little bolt in a slot here. The pin slot mate allows you to locate something like, I give the example of a bolt in a slot. And it gives you a linear degree of freedom and also a rotational degree of freedom. So it can spin inside of the slot and move in one direction. Right? Now, a tip about the pin slot, select pin slot mate from the toolbar. I'll select the mate connector at the bottom of the bolt and a mate connector at the corner of the slot. Now, the biggest tip I can give you with a pin slot in particular is make sure to animate. It's very easy for the linear degree of freedom to not be in the direction you're expecting. You'll notice as I hit animate, the bolt is free to move, but it's not moving in a parallel direction with my slot. Right? So an example or an answer to this is to orient the secondary axis until it is. Right? So that's going the wrong way. Let's flip it twice. And now it's moving parallel with the direction of my slot. Right? Now, again, I mentioned before limits. You could also set individual limits. So I could give a value, for instance, of 0, minimum 0.625, maximum, and it would only allow it to move that 0.625 and then stop. Okay. So as I mentioned before, you can limit the range of motion. You can add individual offsets to your mate. So if you don't want them, for instance, the planar mates, I don't want them touching, but I want a small gap. That's an example of an offset. But again, it's all about restricting that range of motion. Okay. And there's actually another tool I'm going to show you in just a moment that also works in that scenario. And it's what's referred to as a tangent mate, which we'll cover here in a second. So let's move on. Now that was, again, the pin slot mate. The key tip there, again, you're just selecting a mate connector from whatever you want to locate in the slot, and then a mate connector on the slot itself. The key thing there is make sure to animate, make sure that the secondary axis is going the right direction. Okay. So, next one, ball mates. Now, the ball mate, the example I always give with a ball mate is a swivel, and I think it's a very common example where you want to be able to rotate in any direction, but it can't move in any linear direction. So here is an example of a hexapod tray, and if you look, I don't have any swivel mates attaching the eye to the swivel itself. So this is an example where, of course, I want to attach the swivel to the eye, but it needs to be able to rotate in all directions, right? A great example of the ball mate. So I select ball mate, I select the center of the swivel, and I'll select the center of the eye, and it mates the swivel to the eye. One thing I want to point out, though, is notice the parts on the left. It's important to point out as you're adding mates in Onshape, we only solve for the active mate between the active parts. And so in this case, these mates are not being respected, but you can hit solve and fix that, right? And so if you hit solve, it will solve for all the mates in the assembly and everything will update. One thing I want to point out is if I hit play, notice it's free to rotate in all directions, okay? And if I grab and pull, you'll see it's free to spin, okay? So that is the ball mate. Again, the example I like to give is a standard swivel. So next one in my list is the tangent mate. And I mentioned this one just briefly a moment ago. Tangent mate is very simple, and it's useful in a number of different examples. I have a very simple one here where I want to locate a pin in a more complex slot. And the neat thing about this is it will automatically propagate. So let me show you how this works. You'll see the tangent mate in the toolbar. You can select a face, in this case of the pin. I can select a face attached to the slot, and it mates that pin to it. And it mates it tangent to the faces. And notice that it mates it automatically tangent to all those connected faces. Okay, so very easy way to attach it. Another example would be a cam to a follower. If I needed something like a cam to a follower, a tangent mate is a great example of how to accomplish that. So that's the tangent mate. Again, you're really just selecting. You can use faces or edges as well, but it will automatically propagate and find all the tangent connected faces as a reference. So very useful one. Again, something like this where it's a pin and a slot, or you have something like, for instance, a cam and a follower, tangent mate's going to be a useful one. So let's move on. Now we've covered all the different mate types. What I'd like to get into next is what happens when the default mate connectors don't work out for you, when you need a solution that's a little bit more custom. So I want to walk you through an example of that. Now, there will be situations when you're adding your assemblies or you're building your assemblies that you can't select the point that you want. Remember, as I mentioned before, we're taking a point from one part and a point from another. And a great example of this is I'm trying to attach a bike spring to its shock. And the problem with the spring's shape is that when I go to select, for instance, fasten, and I go to highlight, there really isn't a good mate connector that gets referenced here. As I move this thing around, you'll see that it's really just the end points. There's no real central point that allows me to attach it to the shock center point here. So this is an example where I would need a custom mate connector. And you can really think of custom mate connectors as kind of like the Swiss Army knife. They allow you to take a point relative to your part and establish that point as the point of movement or motion. And so it's very valuable because in this case, I may be attaching this spring to dozens of assemblies. And it makes it a very easy way to define, here's my attachment point, and makes it easy to mate in the overall assembly. So let's walk through that. Now, in this case, there's two places you can do this, and I want to point them both out. First off, you can create mate connectors in the assembly. And I do want to point that option out, although it's not what we're going to do here. If you wanted to create a mate connector just in this assembly and use it as reference, that's fine. You'll see the icon here. However, what I would like to do is add the mate connector to the spring itself. And this allows me to take this spring and put it into other assemblies and still have that mate connector come with it. Now, another tip, just an aside from the assembly topic, one of the easiest ways to get to a part studio from the assembly is to right-click the part. So I can right-click the part in the assembly, and you'll see the switch to and then the part name. It makes it very easy to just right-click the part and jump into the part studio without having to go through the tabs. So I've switched to, this is the part studio for the spring. Now, if you haven't created a helix yet in Onshape, and that's obviously what drives the spring here, you'll see that the cylinder is what's driving the spring diameter, the spring length, and so on. So it has a lot of the information about the spring in it. And the neat thing about this is it makes a great reference, the center of the cylinder, makes a great reference for my mate connector. Okay, so let's walk through that. Now, again, I'm in a part studio. So I'm in the part studio that generated the spring. And you'll see the mate connector command on the far right. I select mate connector. I select where I would like to place the mate connector. Right? In this case, it's the center of the cylinder. Now, very important to point out, you must define, in this case, what part is the mate connector attached to. Remember, this construction cylinder is a part in the part studio. So I'm going to make sure to choose the spring. Right? I want this mate connector to belong to the spring. I hit the green check OK. And now when I go back to the bike shock, notice I have a mate connector at the end of the spring. Okay. So I can then fasten, select the mate connector, select the mate connector I want to attach it to, and there we go. So again, there will be those scenarios where you don't get the exact point that you want to reference for your mate, and you can create your own with a mate connector. And you can use just about anything as a reference. So I used the face reference for the cylinder. You could use sketch geometry. There's all kinds of cool things you can do with custom mate connectors. But think of mate connectors as attachment points, and you can define your own attachment points with the custom mate connectors. And it may not even be that by default, you can't select the point you want. It may just be that I want it always in a certain orientation and facing a certain direction. And a custom mate connector solves that problem. So there's lots of reasons to create custom mate connectors. Like I said before, they really are kind of like a Swiss Army knife. If you find yourself always attaching a gear and then rotating the mate connector because it's always a little bit off, create a mate connector, add the rotation, and you don't ever have to adjust the mate again. So all kinds of cool stuff you can do with custom mate connectors. Okay, so that is custom mate connectors. The next examples I'd like to get into are relations and a few of the different relation types that we have. And I want to start with a simple gear relation. Now, a gear relation, I just have a real basic example, is I want to set a rotation ratio. So for every one rotation of this gear, I want this to rotate a certain amount. So the key thing here is you'll find all the relations on the far right of the assembly toolbar. I'll start with the first one, which is the gear relation. And I'll select the two gears from the feature list. Right? Then I set the ratio. And now you could count number of teeth, you could count, pitch diameters or whatever you use as a reference. But essentially you want for every one rotation of this revolute mate, how many rotations of this. So I can hit the green check OK, and now when I grab and drag, you'll see that as I rotate one, the other rotates at a certain ratio. Now, a tip, you'll notice that I'm having a bit of an issue with the teeth meshing. If you just simply mate two gears together, unless they were modeled in that orientation, they won't mesh. And a tip for that is editing the mate connector itself and adding a rotation value. Okay? And there's no real exact science to it, but you can add a rotation value until you get the value where the teeth are meshing, right? So just a tip, and that's more specific to gears in general, but just a tip again, you can edit these mate connectors and set them to anything you'd like. I could rotate them around or offset them in any direction. And also very neat is if you don't know the angle, you can select a reference on the model as your primary and secondary axis. So you can say, okay, this is my X and this is my Y, for example, and realign it with your part. So that is the gear relation. Again, the key thing with a gear relation is you're using predetermined or predefined revolute mates. So you're just defining a ratio between two revolute mates, which of course means you must first have the revolute mates in place. And you'll find that with all these relations, they're dependent on mates already existing, and we're just setting a ratio between the mates. Okay, so that is the gear relation. The next one on my list is screw relation. And for this one, I'm actually going to go back to the machine vise. So this is the example from earlier. And what I'd like to do is define a screw relation so that when I twist the handle, it drives it in a certain amount. And when I rotate it backwards or the opposite direction, it drives it back out, right? So for this, we use a screw relation. Now the key mate, as I mentioned before, with all these relations, they're dependent on mates. The key mate with a screw relation is the cylindrical mate. The cylindrical mate has a rotational degree of freedom and a linear degree of freedom. And so what we do with a screw relation is we say for every one rotation, how much linear travel? Right? So in this case, a 1/2 inch of linear travel for every one rotation of that cylindrical mate. I can hit the green check, and now when I spin, you'll see it drives it in, go the other direction, drives it back out. So getting that realistic screw-like motion from your assembly, the key thing there is having a cylindrical mate to reference. So that is the screw relation. Let's move on. My next example is rack pinion. So let's jump back. This is the arbor press. And what I'd like to do is define a relationship between this and this, so that essentially as I rotate one, the other moves with it. Now, the key thing here, and with any rack pinion relation, is a slider and a revolute mate. Okay, so I select the rack pinion relation. I select my slider mate, right, which has the linear degree of freedom. Then I select the revolute mate, which has my rotational degree of freedom. Okay. Now, the last step here is just to define the amount of linear travel. So for every one rotation of this handle, how much linear travel should I get? And in this case, it's 2.25. Now a tip, again, a green check. If I drag and move and I find, oh, it's going the wrong direction, it's going the opposite of what I would expect, all of these relations have the reverse direction option. So if you find that your relation is going the wrong way, simply go back and check reverse direction. Okay. So then I'm getting more realistic rack pinion motion out of this arbor press. Now, the last relation that I have for you is the linear relation, but there's one last thing I want to point out, and it's more of a general note about all of these relations. In this case, we're choosing a slider and a revolute mate, and it has the exact degrees of freedom needed by a rack and pinion relation. But keep in mind, you can choose other mate types. So if I had a planar mate or a combination of planar mates, for example, that located this, try selecting that here. If your mate has more degrees of freedom than the relation allows, you're going to see a different dialog popping up asking you to choose which degree of freedom do you want to reference. So these are the constraints that perfectly position the relation. But if you have other constraints locating your parts, that doesn't mean it won't work. Just simply try them and you'll see the degrees of freedom pop up, and you can say, okay, I want to along this degree of freedom relative to the mate. So just give it a shot again. Don't be afraid to try it because you don't have the exact combination of mates. Keep in mind you can choose other mate types and then specify what movement you want to allow. So that's the rack pinion relation. The last one on my list, as I mentioned, is the linear relation. The linear relation just ties two slider mates. And the example I like to give are guides along a rail. So here I have these guides that slide along a rail. And what I want, of course, is these two tied together so that as I move one, the other automatically moves with it. Now that relationship is a linear relation. Right? Now, the key thing to keep in mind with a linear relation is it's dependent on two slider mates, right? Or again, as I mentioned before, that same degree of freedom, one linear degree of freedom. So if you have a different mate type, you'll need to specify it. But keep in mind, what we're doing here is we're essentially tying these two degrees of freedom together. So when I hit the green check and I left click and drag, they now both move together. Okay. So again, all I'm doing is tying those two mates together. Now, you can do other things. So I can set a ratio. So for instance, if I wanted one to move twice as fast as the other, I could set the ratio here. And now when one moves, the other moves twice the speed. Okay. You can also have them move in different directions. So we'll set this back to 1. I'll check reverse direction. And when they move in opposite directions. Okay, so that's the linear relation. Again, all I'm doing is taking the two slider mates or those two linear degrees of freedom and tying them together so that they move together. All right, so that is almost everything that I had planned here for you today. There are really two final things that I want to point out, and then we're going to call it a day. And the first is what we refer to as snap mode. So I'm going to jump back here to the casting fixture, and I want to delete the fasten mate. And as I mentioned before, if you want to ever edit or change any of the mates, you right-click them. Well, you can also right-click and delete the mate from the feature list as well. But as I drag the part out here, what I want to point out is what we refer to as snap mode. And I showed you before how we can select the mate, select a point from each part, and mate them together. But there is a bit of a different approach, and it's a lot faster if you get the hang of it. And so if you have a lot of mates that you need to apply, and maybe you like to add a dozen parts at once and then go through and mate them all together, snap mode can be a very advantageous thing. And like the name implies, essentially what it is a mode that allows you to drag one part over another and automatically mate them. So I'll turn on snap mode, left click it in the toolbar, move my cursor over the part, and you'll see again the mate connectors appear. So again, at this point it's very similar to what you may seen when you're creating a regular mate. However, the difference is now I can take the mate connector that I want and drag it, left click and drag it, and automatically attach it to the mate connector I want to attach it to. Right? A mate dialog appears, choose your mate type, green check, and now I'm ready to mate my next part. So instead of, again, selecting the mate connector, okay, you just turn on snap mode and drag one over another, and it automatically mates them. Okay. So it's just a faster way of assembling your assemblies with all the various mates. Turn on snap mode and just start dragging mate connectors one over another. Now, the last thing that I wanted to point out to you is a command called replicate. Now, the question often comes up, can we do things like, pattern parts or insert many different parts at once? And the answer is we have a replicate function that allows you to do something like that. So here I have this casting fixture, and this is a much bigger assembly than we were looking at a second ago. A second ago, we were looking at one of the clamps of this assembly. Now, what I'd like to do is insert one of those clamps and then replicate it around the assembly in all the places you'd want to attach it. So let's do that. The first step here is to insert the assembly. Right? So I'll insert, choose Assemblies. I'll choose the work holding clamp. We'll place it out here in space. So now I've inserted my work holding clamp. And of course, what I like to do is mate it, right? So we'll select revolute. Actually, we'll fasten this part of the cylinder to this part in the base. So now I've placed my first clamp into this fixture assembly. All right. But of course, what I want with this is many of these clamps going all the way around this assembly. And this is a great example where replicate comes into play. So I select replicate. I select my seed instances. What do I want to pattern? All right. Then I select planes to find match in. And that just simply means I select a face and it looks for any similar geometry and patterns those parts to all those points, all those matches that it finds. So you'll see that it's found a number of matches, similar holes in the face, and it's patterned all the parts to those holes. So again, replicate allows you to pattern a lot of parts all at once using the face as a reference. It automatically finds any of the geometry that is identical and patterns the parts to those places. Very useful, like in this example, for attaching fixtures, for instance, attaching many different bolts to a plate, for example. This is a very useful command. It just allows you to very quickly identify the same feature and pattern the same part or parts. Okay. So that is what I had planned for you today. There is one last thing I wanted to point out, and that is just something that, a subtle thing that I want to mention. And that is, you may have noticed that we initially were working in the work holding clamp subassembly, right? And our clamp here was a very simple mechanism. Then we stepped into a much larger top level assembly. The question often comes up, well, how does the subassembly behave? And it's important to point out, and this is if you have experience with other CAD systems, the mates of the subassembly are respected in the top level. They're what's referred to sometimes as flexible. Your subassemblies are flexible in the top level. Okay, so you have all the same mates. You have support for the ability to insert subassemblies inside of other top-level assemblies and organize things in that way. You can even create subassemblies on the fly. So you can move to a new subassembly, create new subassembly, and these are all in the right-click menu. So for those that really like to organize their subassemblies into top-level assemblies, that functionality, that capability is fully supported here. Okay. So that is everything. Now, one last thing that I wanted to mention before I let you go is going forward, if you're just getting started with Onshape, we really encourage you to try it in your professional environment and let us know what you think. There's a feedback tool that's built in the help menu. In the top right, you'll see feedback. Give us your feedback. Let us know what you think. We really encourage you to do so. We really take feedback very seriously. Also, invite others and share. If you haven't shared your document yet, there's a big share icon in the top right. You can work together in real time. You can communicate with comments. You can see each other's screen with follow modes. All kinds of cool stuff comes into play when you start sharing. The last thing I want to mention is if you're interested in meeting local users or maybe interested in establishing your own user group, let us know. We'd love to hear from you. So that is what I had planned. I'm going to stick around and answer any questions that you have. So feel free to ask any questions you'd like. But that's it, everyone. Thank you, and have a good day.